Hello students, the question says a parallel plate air capacitor has a capacitance C. When it is half filled with a dielectric of dielectric constant phi, the percentage increase in the capacitance will be. So let me redraw the diagram. So there are a parallel plate capacitor. Let us assume the distance between these two capacitors is T and the area of these plates is A. Now he has given the word half filled. What do you mean by half filled? Generally, there are two ways we can half fill this. One could be in this way. You exactly fill the lower half and you leave the upper half as it is. Or you can fill half fill in this way. So one would be filling the entire area and you are exactly filling half of it. Or you won't fill the entire area, you will fill the entire distance. So both of them could be half filled. But let me tell you, in our syllabus, whenever you hear the word half filled, we will start filling along the distance only. Unless mentioned, we will always assume that whenever it says half filling, we will assume that it is filled along the distance. That means we are not disturbing the area. Area of this dielectric slab would be equal to the area of the plate. The only difference would be the distance would be disturbed whenever we say half filling. So first you have to be clear in that. So it is half filled. This would be D by 2. So once we know this, we have to, and he has given a dielectric of phi. So this slab has a dielectric of phi. We know generally the default formula is C naught equal to epsilon naught A by T. This is the original formula. Once we fill something between the plates of the capacitor, example, if thickness T is filled, okay, then the new capacitance would become C naught into D by D minus T plus T by K. This is the formula for new capacitance if a capacitor, if a dielectric is filled between the plates of a capacitor compared to the original one. So how we got this formula, I'll derive this at the end of this video. So first let us use this formula to solve this. We got C naught D divided by D minus D by 2 plus D by 2 into 1 by K value is 5. So we'll write C naught D, but D minus D by 2 is D by 2 plus D by 10. So I'll take it to the next page. So we get C nu equals to C naught D divided by, if I get D common, I'll get 1 by 2 plus 1 by 10. So we'll get C naught into 10 2s are 20, it will go to the numerator. 10 plus 2, it will become 12. So we got C naught 10 by 6. So 10 by 6 is C naught into, this value would be 1.66. So we got C nu is equals to 1.66 C naught. He is asking you percentage increase. So percentage change would be the final value 1.66 C naught minus initial value C naught divided by C naught into 100%. You can clearly say we are getting this as 66.6%, which is our option B. You might wonder how did we got the another 6? We can write this as 1.66666 so on, and we'll eventually get our answer as option B. Hope you understood how I have solved it. Like, as you can see, the key part was using the formula directly. Now, if you need the derivation of this formula, I will quickly derive this. Suppose, imagine we have a capacitor plates and till a thickness T, we have placed a dielectric. So we have placed a dielectric of dielectric constant K, and its area of this plate is A. So originally we can write C naught equals to, without any dielectric, epsilon naught A by D. Now I have placed this dielectric. If I place this dielectric, I can divide this entire capacitor into two parts. One is thickness T, the total thickness between the total gap between the plates is d. So only this part would become d minus t. So this is one plate, this is another plate. Let me call this as C1 and C2. So I'll get C1 equals to K epsilon naught A by the gap between them is T. C2 would become, there is no dielectric, epsilon naught, area of the plate is A, divided by the gap between these two is D minus T. So if I rearrange them, you can see, I can redraw this diagram as this one would become C1, this one would become C2. It's like two plates in parallel. When two plates in parallel, if you want effective value, so C effective would be 1 by C1 plus 1 by C2. So which is nothing but T by K epsilon naught T plus D minus T by epsilon naught E. So I will take it to the next page and we'll solve it over there. If you see this, we can get 1 by epsilon naught A as common. If you get 1 by epsilon naught A as common, you will get T by K plus D minus T. This is what you get in numerator as 1 by C effective is nothing but the original one. So reverse this now. Simply C nu would be epsilon naught A divided by T minus T plus T by K. And we know epsilon naught A. What is this epsilon naught A? If you compare with the original one, we get epsilon naught A equals to C naught into D. So we can write this as C naught into D by D minus T plus T by K. It is better for you to remember this formula rather than deriving it every time. So whenever the plates of the capacitors are filled, you should see how they are filled. They have to be filled along the length. Imagine the plates, these are the plates of the capacitor and they are filled not along their distance. What if the plates of the capacitors are filled along this area? If it is filled in this way, you cannot use this formula. For these cases, this formula is not used. But generally in our syllabus, whenever he says the plates of the capacitors are filled, it is not filled along the area. It is actually filled along the distance. So this is the default condition we will assume. This is K, this is T, and this is total D. So this part would become D minus T. And this is the area of the plate. And to find the new value, we will use this formula. Hope you understood the derivation part. If you already know the derivation part, you could have ended it only here. You could have solved directly and stopped here. This is the method to solve this. Hope you understood. Thank you.